Hello everyone, my name is Arthur Morris and welcome to Solving Absolute Value Equations. Now remember, when you take the absolute value of something, it means the distance away from zero. So many times there can be two solutions to these equations. For example, the absolute value of 7 equals 7. However, the absolute value of negative 7 also equals 7. So many times you can have two solutions to the equations we will be solving. So your first step when you're solving absolute value equations is to isolate the absolute value to one side of the equation. Meaning, if you have something that is outside of the absolute value symbols, you want to make sure that it's moved to the opposite side of the equal sign. Step two is to check to see if it is a valid equation after you isolate the absolute value symbol. Remember, when we take the absolute value of a number, it must be greater than or equal to 0. So, for example, if I have the absolute value of x plus 2, and they tell me that it's equal to negative 4, well, I know that it's not possible because the result of taking the absolute value of something will give me 0 or something greater than 0. So to take care of our two possible solutions, we create case 1 and case 2 is what I call them. Case 1 is our regular case. We leave everything like it is except we drop off the absolute value symbols and we solve the equation. Case 2 is our negative case. So we leave the left-hand side like it is and we make the right-hand side negative, or we multiply by negative. We solve each equation and we will have both of our answers. Okay, so let's look at a few examples. The absolute value of x equals 8. So I'm looking for the possible numbers that could replace x. So the absolute value symbol is already isolated. So case 1, x equals 8. Leave it just like it is. Drop off the absolute value symbols. There's nothing for me to solve in this case, so that's one of my solutions. Case 2, which I like to call the negative case, the x stays the same. However, the number on the right-hand side, its sign changes. It goes negative 8. So those are my two possible solutions. I could plug 8 in for the absolute value of x, and the absolute value of 8 equals 8. The absolute value of negative 8 equals 8. So that's my solution set. Okay. The absolute value of 2x plus 10 equals 30. So as you can see, on the left-hand side, we have a plus 10, which is not inside the absolute value symbols. The first thing that we want to do is to move this plus 10 using our addition principle. We would subtract 10 from each side. So now we get the absolute value of 2x equals 20, which is valid. I can take the absolute value of something and get positive 20. That's okay. So here is where I will create my case 1. 2x equals 20, and solve the equation. So I have 2 times x. To undo that, I would divide by 2, and x equals 10. Case 2, that is our negative case. Again, the left-hand side stays like it is. The right-hand side becomes negative, or the sign changes. And then I solve again. Divide by 2, divide by 2. X equals negative 10. So my solution set, negative 10 and 10. Now, the numbers will not always be exact opposites for your solution set. Sometimes you may get 3 and 5. So the numbers will not always be exact opposites like we've had on the last two problems. Okay, let's take a look at this one. We have the absolute value of 8x plus 3. Then outside of the absolute value symbols, plus 11 equals 8. So again, you want to isolate the absolute value symbol. So I need to move this positive 11 first by subtracting 11 from each side. So now I have the absolute value of 8x plus 3 equals negative 3. Step 2 said to, once you've isolated that absolute value symbol, check to see if it's a valid equation. Remember, when I take the absolute value of something, I have to get 0 or a number greater than 0. I cannot get a negative number. So I can't take the absolute value of 8x plus 3 and it equal a negative number. There's nothing I can take the absolute value of that would give me the result of a negative number. Therefore, my answer here is no solution. So remember, when you take the absolute value of a number, you get a positive result. There is no way that I can take the absolute value of 8x plus 3, whatever number that will turn out to be, and it will equal negative 3. Now, you must isolate your absolute value symbols before you check to see if it's a valid equation. Okay, example number 4 here. This example has the absolute value symbols on each side of the equation, so they are as isolated as they can possibly be. We go ahead and we do case 1 and case 2 still, using the same rules. So case 1, I'm going to leave everything just like it is and drop off the absolute value symbols. Then from here, we just go through our equation solving process. So move the variables to get all the variable terms together. Move the numbers. And if you want to do these 2 steps all in one step, you can. And then the last step, divide by 2, and x equals 9. So that is one of my solutions. Case 2 is our negative case. So again, we leave the left-hand side just like it is. However, we multiply the right-hand side by negative or negative 1. Now, since I had a binomial over there, remember we have to use the distributive property with this negative. It will change both of those signs over there. And then we will solve this equation just like we solved the last equation. Now I'm going to do the next 2 steps all in one step. I'm going to move my variables to the left and my regular numerical terms to the right, my constant terms to the right. So we'll add 3x to get the x's moved over to the left. And I will add 7 to get my numerical terms or my constant terms on the right. So now I have 8x equals negative 4. Last step, divide both sides by 8 and simplify the smaller numbers on top, so that gives me negative 1/2. So my final solution would be negative 1/2 and 9. So if I plug either one of those numbers back in for the x's and simplified, it would make a true statement. Alrighty, that's solving absolute value equations. I hope you found that to be helpful. Thank you.